Okay, should be recording. Okay, so we do have our quiz tomorrow. Is everybody feeling like a little bit more confident about it? I think you're ready for a quiz tomorrow. So tomorrow we'll basically join our Google Meet. I'm probably gonna have like 2 problems for us to just like warm up with, and then I will my friends here will take their quiz, and my friends at home, hopefully you will oblige me and take your quiz during our block. Okay, that would be super cool if you guys could work on that at home for me. So we can talk more about that tomorrow, though. Don't stress out about it. Today, I really just want us to kind of focus on the process of going through these problems, and also a couple of these problems which are just going to be a little bit different. Okay. All right. So let's skip over number 1 for right now. We're going to skip over number 2 for right now. Skip over number 3 right now. Guess we're skipping over all of them. No, I'm just kidding. I think we need to go to the bottom. I'm looking for a percent yield one, and I think we need to go. Yeah, let's slide all the way down to number 7. All right, so there will be a percent yield question on your quiz tomorrow. There's just no way around it, right? So remember, with percent yield, there will be a question, or I guess I should say there can be a question where it basically just says to you, determine the percent yield. So what you have to recognize is, what do you need to find in order to calculate percent yield? You're given the actual yield, right? But you have to find the theoretical yield. All right, that kind of sometimes like trips people up. All right, so let's take a look at this one. We're gonna find the percent yield, obviously, between 3.74 grams of sodium. All right, so there's one of our reactants. Excess oxygen gas, cool. If 5.34 grams of sodium peroxide is recovered. All right, so then this value here, this 5.34 grams of sodium peroxide, that's your actual yield. All right, so you're given, we can actually fill this out before we even start, is 3.74 grams of sodium, which is Na, and we are going to try to find the grams of sodium peroxide. Can anybody tell me what the formula is for sodium peroxide? No. Na2O2. Na2O2, beautiful. All right, peroxide, guys, is O2 with a -2 charge. It's one of our polyatomic ions. It's a weird one, so just be, conscious of that. All right, we know the drill. The first thing that we want to tackle here is actually writing out the balanced equation. So they tell us that we're reacting sodium. Don't give us a phase for that. Excess oxygen gas, so O2 gas. And then it's going to produce the sodium peroxide that we just figured out the formula for. So for Na2O2. All right, go ahead and balance this one, guys. Shouldn't be too tricky. Anybody get the coefficients? John? 211, he says. All right, cool. Now we're ready to start our problem. All right, so we're going to go from grams of sodium to grams of Na2O2. Is there anybody here in class who is going to use a BCA table? No takers on the BCAs. What about my virtual peeps? Anybody, you can just type into the chat. Anybody going to use a BCA table? I I see no responses, so I'm going to assume that nobody is going to use a BCA table. All right, cool. So we'll just do the traditional method then. And let's go ahead and get started. So we'll begin with our 3.74 grams of sodium. Over 1. All right. Looking at your units here, we're going to need grams of sodium in the denominator. All right. Think about your two conversion factors, right? You can either use molar mass or mole ratio. As soon as you see that gram there, you should be thinking this has got to be molar mass. So I find sodium, we can round its molar mass to 2 decimal points. So I would round that to 22.99. All right. 1 mole of sodium goes with that molar mass of sodium. I have to keep going because it's asking me for grams of sodium peroxide, right? Well, specifically, it's not asking me for it, but I know that that's what I need to calculate here. All right. On the bottom, I'll go ahead and put moles of sodium so that I can cancel out those units. And we're looking for moles, we're looking for sodium peroxide. So let's go ahead and put moles of sodium peroxide on the top. All right, this is going to be our mole ratio, right? Moles over moles, that's got to be mole ratio. It can't be molar mass, okay? So when I'm looking at mole ratio, I'm looking at the balanced chemical equation. I'm looking at the coefficients. There's a 1 in front of the sodium peroxide and then a 2 in front of the sodium. All right, I can't stop here because I need grams, so I got to keep going. One more step. I'm going to go ahead and follow suit with the units. So I'm going to put moles of sodium peroxide in the denominator and then grams of sodium peroxide on the top. Again, as soon as I see that grams there, this has got to be molar mass. All right, so just slide this up. We'll go ahead and calculate the molar mass for sodium peroxide. Should be pretty straightforward, right? 2 times sodium, 22.989770 plus 2 times oxygen, which is our 15.9994. I'm going to double check my molar mass here. Could be 77.98. We'll double check it. Okay, 7.98. That's it. And we'll put a G/mole, grams per mole. All right, remember that value is going to go into our conversion with the gram of sodium peroxide. So we'll go ahead and put 77.98 on the top. And then, as always, 1 mole goes with molar mass. All right, that's our definition of molar mass. All right, we're ready to calculate here, guys. So remember, we're going to multiply straight across the top, 3.74 times 77.98. And then I'm going to hit divided by parentheses 22.99 and divided by 2 again. And I get, sig figs. We didn't talk about those yet. 3 sig figs. So I get 6.34 grams is my final answer. Okay, I'm going to put a box around that, or a circle rather, and I'm going to label this as my theoretical yield. All right, guys, I'm going to tell you this right now. You're going to have to do this on the quiz tomorrow, okay? So the format of the quiz is going to ask you, like, What's the theoretical yield? Write it right here. Okay? It's not that deep, right? The theoretical yield is the grams of the product that you found. Okay? Don't let that confuse you. That people get hung up on that all the time. They're like, I did all this work. I don't know what this is though. It's a theoretical yield. Okay? There's like not a lot of things it can be, right? All right. One last step though, right? We have to figure out the percent yield. So percent yield is actual over theoretical times 100. Actual has to be given to you. They tell us 5.34 grams is recovered. So that means like that's what they found in the lab. So I'm going to put my theoretical, which I calculated, on the bottom. And then it's a percent, so we're going to multiply by 100. I'm going to double check my math on this one too. All right, we're still looking for 3 sig figs here, so 84.2% is what I get. And I'm going to label that also and put a circle around that because technically I found 2 things in this problem, right? And I'm going to label it with a percent and a yield. Okay? We can also come down here and write it on this nice little line. Just to be really clear. All right, where are your questions or concerns on a problem like this? Everybody's okay? I feel good. All right, so I know number 8 is another percent yield question, so I don't want to do that one with you because I want you to like practice it on your own. What I do want to do is come back up to question number 6. Okay. Now this is going to be a little bit different than what we have been doing like yesterday, I guess. So let's see if we can't figure this one out. Okay. So they give us the nice balanced reaction. That's really nice and helpful. They ask us to find how many moles of aluminum oxide would be produced if the reaction started with 16 moles of aluminum. Now, what's different about this is we've gotten used to starting with grams and ending with grams, right? Here's the good news. This is going to be a lot less work than what we just did for percent yield, okay? So let's identify our given and our find. Let's see if we can't use our Unit 5 conversion knowledge to figure out how we're going to solve this. So we're going to start with the 16 moles of aluminum, right? That's our one reactant. And then they want us to find moles of the aluminum oxide, which is the Al2O3. That's the product there. All right, let's start this by setting it up, starting with our given over 1, same deal like that we've been working with since Unit 5. So 16 moles of aluminum over 1. Now look at your units. You know that you need moles of aluminum in the denominator. Can I put moles of Al2O3 on the top? Yeah, I can, right? This is a mole ratio. That's all that is. All right, where do I get those values? I get them from the balanced chemical equation, the coefficients. So there's a 2 in front of the Al2O3, and then there's a 4 in front of the Al. Stop and think here, guys. What is this going to leave you with for a unit for your answer, right? Your moles of aluminum are going to cancel out. You're going to be left with moles of Al2. What did I want to find? Moles of Al2O3. So guess what? You've done this problem. All right. Okay, well, we have to solve it, but basically you're done. All right. 16 times 2 divided by 4. Can anybody do that in their heads? Ava. 8 moles of Al2O3. Boom, done. That's a nice, easy problem, okay? You can expect to see a problem like this, if not on your quiz tomorrow, perhaps on your quiz. I don't want to spoil the surprise. If not on your quiz tomorrow, then on your Unit 8 test. All right? Now, let's practice this again with letter B. It says, how many moles of oxygen gas would react with 16 moles of Al? So our given is the same this time, right? It still has us dealing with the 16 moles of aluminum, but now it wants me to find the moles of oxygen gas All right. Guess what? We're going to set it up the same exact way as we did the last one. So let's start with our given over 1. All right. Moles of aluminum in the denominator. Okay. Set your units up first. I'm looking for moles of O2, so I want that on the top. This is my mole ratio. My mole ratio needs the coefficients from the balanced chemical equation. So we've got a 3 in front of the O2, and we've got a 4 in front of the AL. How are we feeling with this kind of problem? Is it okay? It's all right. Okay. All right. Can anybody do that one in their heads? Basically, 75% of 16 is
12.
12. Yes. You can use your calculator. I'm just good to wake up the brain with some mental math, right? All right. Excellent job, guys. All right. So you know what? Let's go ahead and just finish off this question, only because I want to show you letter D. We won't just skip letter C. Or letter C. We can't leave them out. All right. So this one starts us with 27 moles of the aluminum oxide, the Al2O3. How many moles of oxygen gas did the reaction begin with? So we're looking for moles of O2. It's going to be the same process, guys. It's just different units, right? So 27 moles Al2O3. All right, moles of Al2O3 in the denominator. Moles of O2 on the top. Coefficient in front of the Al2O3 in the balanced chemical equation is a 2. Coefficient for oxygen is a 3. This one might be a little tricky to do in your heads. It comes out to be 40.5. But how many sticky figs do we have here? Only 2. So we're going to have to round this guy up to 41 moles of O2. All right. Yes. Oh, John, that's not a question, is it? Okay. So let's tackle letter D here. It's just going to be a little bit different. I have faith that we can figure this out, though. So it says the reaction is going to begin with 200 grams of aluminum. How many moles of oxygen gas will the reaction require? Okay, so this is a little bit different because, well, you probably recognize this. We're going to start with grams, which we've done that before, but we want to end with moles of oxygen. Okay? Guess what? It's still going to be less work than going grams to grams. Okay, that's the good news for you. All right, so let's see how this all pans out. We're going to depend heavily on figuring out how to set things up based off of our units, right? So we're going to start with the 200 grams of aluminum over 1. I'm going to go ahead and put grams of aluminum in the denominator here. So what do I need here? Is this going to be a mole ratio or is this going to be a molar mass value? Molar mass value, okay? So I'm looking for aluminum on the periodic table. It's number 13, 26.981538. Let's round the two decimal places, so 26.98. Always 1 mole with our molar mass. Okay. Now, again, let's set up the next step with our units. So we're going to have moles of aluminum in the denominator. I'm looking for moles of O2. So let's put moles of O2 in the numerator. You know the drill. This is a mole ratio. So we're going to be looking for our coefficients in our balanced chemical reaction. You might have to go all the way up. The aluminum has a 4 and the oxygen has a 3. All right. What do you recognize now? Look at the units. My grams cancel out, my moles of aluminum cancel out, and I'm left with moles of O2. So guess what, guys? We're ready to solve. All right. So this is basically just like one less step than our grams to grams, right? Because if I wanted grams of O2, you would then include in the next conversion the molar mass of O2. Okay. So when they ask you to go from grams to moles, it's just one less step. Now, a lot of people are like, oh, I have to memorize all these different types of problems. No, you don't. Okay. All you have to do is know how to set things up based on the units. Okay. Look at what you're trying to solve. Look at what units you're left with. Look at what units are canceling out. All right, let's do this math here. So 200 times 3 divided by 26.98 divided by 4. Well, we're looking for actually one sig fig here. That's annoying. So we end up with, let me write down a little bit of what the calculator tells me. 5.55 6, 7, 3, 8, 3, 2. We would never, ever have a number like that, right? That is way too many sig figs. You're never going to start with a number with that many sig figs. So this situation calls for one sig fig. So we're going to round this up, right? So we're going to report 6 moles of O2 as our final answer for this problem.
Why would there only be one?
So the 200 is what we're using. That only has one sig fig because those zeros, while they are trailing something significant, right, they're to the right of the 2, they're actually just placeholder zeros, right? You probably won't see a number like this on your laser test. Kind of a weird number to start a problem with. All right, how are we feeling, guys? You feeling okay? Do we want to do more together, or do you want to work on your own? One more together? Sure. Let me pick a good one. They're all good. Who am I kidding? All right, I want to save 8 for you guys. Let me go ahead and pick one of the harder, like, reaction ones so we can get that out of the way. Let's do 2 together because this is like lead sulfide. Actually, this is a good one too to do together. All right, lead 2 sulfide, PBS, reacts with oxygen gas to produce lead 2 oxide and sulfur dioxide. All right, so we're going to start with 0.500 moles of O2. So let's break down our given and our find here. All right, they want us to find how many grams of lead 2 oxide would be produced. All right. Lead 2 oxide is going to be PbO. I know that because the 2 here tells me that lead is going to be a positive 2. I know that oxygen from the periodic table is a -2. Let's go ahead and figure out our number of sig figs. How many sig figs do we have here? I'll give you 2 options. Do we have 1 or do we have 3? 3? How come those zeros are significant now? They're after what? You're right, they are after something.
They're after the.
They're after the 5, which is significant, right? And they are after the decimal point. Remember, it's that 2 conditions there. Because the 200 in the other problem, there was no decimal point, those zeros weren't significant just because they were trailing a significant figure. These zeros right here, these 2 fit the bill because they trailed the decimal point and something significant. All right, first things first, we're going to write this reaction out. So we've got PBS, oxygen gas, producing the lead 2 oxide, which we already figured out is PbO, and sulfur dioxide. Ooh, some Unit 6 knowledge needed there. All right, you guys go ahead and take a moment. Let's balance it. Can be a little tricky to balance, actually, just a little bit. Careful with your O's. Don, you got it? 2322, yes, sir. All right, my friends, let's go ahead and see what we're going to work with here. So we're going to start with our given over 1. So the 0.500 moles of O2 over 1. All right, following my units here, I'm going to put moles of O2 in the denominator. Now, I need to think about this, right? I'm starting with moles of O2. Is there any reason for me to go to grams of O2? What am I trying to find? I'm trying to get to PBO. All right. So what you might recognize, hopefully, is I can put my moles of PBO up top here. We can use our mole ratio, and then we're going to use the molar mass of lead 2 oxide to find the grams. Okay. So again, this is like one less step than your normal grams to grams. All right, so the coefficient in front of O2 is a 3. The coefficient in front of the PBO is a 2. So we can fill in those numbers. Okay, if I stopped right now, I'll look at the problem. If I stopped, I would have moles of PBO as my unit. Not what I want, right? The problem is asking me for grams this time. So let's put moles of PBO in the denominator and grams of PBO in the numerator. Okay, now we got to find the molar mass of PBO, so let's go ahead and show that down here. All right, lead is 207.2 plus oxygen 15.9994. Rounding that to 2 decimal places, I get 223.20 grams per mole. All right, so that 223.20, let me write that a little bit better, guys, sorry. 223.20, always 1 mole of molar mass. Now look at your units. We've gotten rid of moles of O2, we've gotten rid of moles of PBO, we're left with grams of PBO. That matches what I'm trying to find, so that indicates to me that I'm ready to solve this one out. All right, I would multiply straight across the top 0.500 times 2 times 223.20, and then I would divide by 3. I'm looking for 3 sig figs. It comes out to be 74.4 grams of PBO, lead 2 oxide. How do we feel? Questions, concerns, thoughts, or feelings? Feeling okay? Do we love it or do we hate it? Okay? All right? Okay. That's fair. All right. You want me to give you the final answers for the rest of them? Do we like that so we can check ourselves? I just have to find all of my work here. So I'm just going to write them with the problem because that'll be a little easier for me. Hi.
Hello.
How are you?
Well, I like all the space in here.
Thank you. Yeah, we're well spaced out.
Exciting.
Got our windows open and cruising. All right, so for number 1, my friends, we've got 44.3 grams of iron. That's my final answer there. All right, I'll give you guys a second to jot it down. Let's see, I think this is our next one. All right, for number 3, your final answer should be 0.979 grams of O2. All right, for number 4, we've got 9.92 grams of sulfur dioxide. All right, I'm going to warn you for number 5, the reaction is tricky to balance. Okay, so you might want to like start with that problem just so you can get help on the balancing if you need it. The final answer for number 5 is 1.39 moles of H2O. All right, last but not least, I think we've got number 8 left at the bottom, which let me find on my sheet. Here we go. You should end up with a percent yield of 85.5% yield of the SB406. All right, everybody okay? Feel well prepared to do these problems? All right, guys. Submit this, obviously, the due date's before class tomorrow. I would work on it today, though, in case you come across a question or concern, right? Just because we have our quiz tomorrow, so you want to, kind of prep yourself for that, okay? I'll leave the Google Meet up, guys, and as always, you can just message me on Canvas if you have a question or concern, okay? Virtual friends, you're good to go. Have a wonderful rest of your day, guys.
Thank you.
Thank you.
You're welcome, guys. Have a great day.
Bye, thank you.
You're welcome.